Hello, it's Mrs. Cynthia again, and today we are going to talk about scientific notation. Okay, we're going to take baby steps into this real quick. It has to do with section 2.1, the patterns of multiplication. As you recall, if you saw, and exponents, the 2.6. So you knew that in section 2.1, we learned that 10 times 250, or let's say 2,500, we knew to do 1 times 25 is equal to 25, and then we tacked on the 3 extra zeros, 1, 2, 3, and that's why we got 25,000. So that was that part, and then in section 2.6 we learned that, let's say 3 to the third was equal to 3 times 3 times 3, which was equal to 3 times 3 is 9, times 3 is 27. Okay, so what we're doing is we're combining these two things right here. Okay, scientific notation is a way to write huge, astronomically huge numbers into and fit it into kind of this space right here. Okay, so if you were looking at, let's say, the fact that Neptune is about 2,800,000, so let's go ahead, 2,800,000 miles away from the sun. Okay. If that's the case, here's Neptune, here's the sun, and this is that far. Instead of having to write this huge number, what we can do is we can turn it into scientific notation, okay, scientific notation, which means we're going to remove these zeros. We're going to stop ourselves from writing these zeros and instead write a nice, small, compact number. The way that we do that is we move the decimal. Okay, but then we say where we took the decimal from. So let me go ahead and just finish this example and then go look at some other stuff. But here's this decimal. We're going to move the decimal all the way over here and then say how far we moved it. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, we moved it 9 times. If we wanted to get it back, we would multiply it by something, and so let's go ahead and say, so 2.8 times 10 to the 9th power. How crazy is that? So what we're saying is we would take this number 2.8 and multiply it by 10 to the 9th power. 10 to the 9th power, when you expand it, is 10 times 10 times 10 times 10 times 10 times 10. To the 9th power, keep going, times 10, 4, 5, times 10 times 10, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so we would say 2.8 times 10 to the 9th power. 10 to the 9th power is actually 1 billion. Okay, so if we were to multiply 2.8 by 1 billion, we would get 2, 8, 1, 2, 3, 1, 2, 3, 1, 2, 3. Oops, 1, 2, 3. Okay, so that's what we're saying. This is the scientific notation. Look how much shorter that is. Look how many less zeros. Talk about trying to put this in your calculator and then multiplying it by another 40 billion, whatever it is. That's going to be difficult for your computer to handle versus, or your calculator to handle, versus handling the 2.8. So when we break it down, let's go ahead and break it down. So scientific notation looks like this. 1.2, let's say, times 10 to the 2nd power. 10 to the 2nd power is 10 times 10. Oops, 10 times 10, which is 100. So this is 1.2 times 100. You know that when it has 2 zeros, we multiply the integers. 1 times 1.2 is 1.2, and then we add on the 2 extra zeros. I'm sorry, we move the decimal over 2 places, and so that's why we get 120. So it's really 1.2 times 100. Okay, that was less clear, I think, than necessary. If we had 2 times 10 to the 3rd power, 10 to the 3rd power is 10 times 10 times 10, which is 1,000. So 2 times 1,000 is equal to 2,000, right? That's what this is representing. This is the exact same number as this number. They both mean the same exact amount. The difference is, with scientific notation, we can shorten that number. And here it doesn't seem that much shorter, right? You have to write 4 characters here. You have to write 4 characters here, if not 5. But when you're dealing with lots and lots of zeros, it makes a lot more sense. Okay, so what you're being asked to do today, okay, is to just go back and forth between scientific notation and standard notation. So again, this is standard and this is scientific. Okay, so let's repeat real quick, just in case I totally lost you at one point or another. You will be asked to say, what will well, actually, let's do this. What will 5.4 times 10 to the second power look like? Okay, what will it be in standard form? And what you will do is you will say, okay, well, I'll expand it to 5.4 times 10 times 10. 5.4 times 100 you could do, and that's 2 zeros here, so you move this little place 2 places, and so it's 540. Okay, that's what this is equal to. Okay, same exact thing. And kind of that's the only type of questions that you might be asked. You may be asked to turn it into, turn 2,750,000 into scientific notation. And what you would do, I'd like to change colors for a second, is you would say, okay, so here's the decimal now. I'm going to move it over 1, 2, 3, 4, 5, 6 places. I'm going to rewrite my number, 2.75. We're getting rid of the zeros. That's what the scientific notation is doing. But I'm going to remember how many zeros I passed. So I did 1, 2, 3, 4, 5, 6. Okay, so this is it in scientific notation. 2.75 times 10 to the 6th power. Okay, you always want standard notation. You have one integer, so you always need one integer here, the decimal here if there is a decimal, and all the other numbers following, times 10 to the exponent. Okay, so there's always one non-zero integer here, meaning just 1 through 9. You can't have a 0 here, is what I'm saying in scientific notation. And then, what's the other thing? Oh, 10 to the first power is really just 10. 10 to the 0 power is 1. Okay, so it might be helpful. You may encounter that. As you're working, we'll definitely be working on this more. Okay, good luck, and I will see you soon.